All right, here is the concept development for lesson 2. The first thing I want you to do is draw a number line and mark your endpoints as 0 and 1. So here's what I mean by that. There's a number line, endpoints starting with 0, ending at 1. Okay, the next thing I want you to do is split that number line into 3 equal pieces. You can estimate, get as close as you can, but there should be thirds when you're done. So it should look like this. Okay, now I want to use your number line to show me with arrows drawn what 1/3 plus 1/3 would look like. So here's what I mean. I have 1/3, here's another third, so using arrows, 1/3 plus 1/3, and in numbers, what does that look like? Okay, so here I have 1/3 plus 1/3, and that equals how many thirds? 2/3. 1/3 plus 1/3 equals 1/2. So this is how to show an addition problem of fractions on a number line. So let's take it one step further. How many copies of 1/3 did I have? I had 2 copies of 1/3. So 2 copies of 1/3 equals 2/3. Okay, that's another way to represent that. I just want you to think about it that way. Let's try another one. Okay, I want you to draw another number line with the same endpoints, starting at 0 and going all the way to 1. And this time, once you have that done, I want you to split it into 8 equal chunks. So estimate and do as best as you can, but they should be pretty evenly spaced. Pause the video while you do that. Okay, so this is what you should end up with. I have 8 equal chunks, which means I'm going to be drawing 7 lines. 1, 2, 3, 4, 5, 6, 7 lines, because this last line makes my 7th and 8th chunk. Okay, this time I only want you to show me where 3/8 would be. So only label 3/8. And that would be right there. 1, 2 on the third one. So I want you to show me what 3/8 plus 3/8 would look like using arrows on this number line. So starting at 0, there's 3/8 plus 3/8. Okay. Now what if we added in 1 more 1/8? Where would we be? 1 more. So I want you to write an addition sentence with numbers that shows me adding 3/8, adding 3/8, and then another 1/8 with the answer. What is the solution to this problem? So you should have written 3/8 plus, and then I added another 3/8 plus a 1/8, and what do I get? 3 plus 3 plus 1 more is 7/8. 1, 2, 3, 4, 5, 6, 7/8. So let's think about this as a multiplication sentence as well. How many copies of 3/8 did I have? Well, I had 2 copies of 3/8. Let's put that in parentheses because those go together. And then I added another 1/8, and that equals my 7/8. Okay, let's do another. Okay, this time I want you to copy your number line down just like I have here. So your endpoints are 0/2 and 6/2. Then I want you to split this into 6 equal chunks, which means you're going to be drawing 5 lines, 1 less than 6. So 1, 2, 3, 4, 5 lines. You can estimate, just get as close as you can. And then I want you to label 2/2, where 2/2 would be. Okay, after you've done that, I want you to label where all of the whole numbers would be. So I mean, 0 halves is the same as 0. 2 halves is the same as 1. Then I would go 4 halves, so there's 2, and 6 halves, which is 3. So I have my whole number equivalents of what 2 halves equals. Now I want you to use arrows to show me what 2 halves plus 2 halves would look like. So I have 2 halves plus 2 halves. Okay, now I want you to add one more 2 halves to that and show me where you end up with that. 2 halves. Okay, go ahead and write down the addition sentence to show 2 halves plus 2 halves plus 2 halves and what it equals. So up here I've written 2 halves plus 2 halves plus 2 halves. And we already know 2 halves and 2 halves and 2 halves equals 6 halves because that's where we ended up on our number line. But the key thing about this is to think about, don't forget fractions are also the same as division. This is the same thing as saying 6 divided by 2, and 6 divided by 2 equals 3, that whole number that we already got to. So if you have an improper fraction, which means that your numerator is greater than your denominator, you should always change it to a proper fraction or mixed number. So 3. Now I want you to write this as a multiplication sentence. 2 halves. How many copies of 2 halves do we have? And we have 3 copies of 2 halves. So 3 copies of 2 halves. This says the same thing as this. Equals the same answer, 6 halves, which is still 3. Okay, are you getting the hang of it? Let's try a couple more. I want you to draw a number line and label your endpoints as 0/5 and 10/5 and make a mark down the middle for now. Okay, if you had to label it, what would you mark as, what would you say the value of this midpoint is right here? If it's between 0 halves and 10 halves, what would make sense to go here? And halfway between 0 and 10 is 5. 5/5. So 0/5, 5/5, 10/5. Now I want you to make 10 equal marks, including this one you already did. So split this and split this so that there's 10 marks all together. It will look something like this. Remember, if I'm making 10 marks, then I'm actually going to draw 9 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9 lines, because this last one makes my 10th chunk. Okay, now I want you to record the whole number equivalents. So what is 5/5 the same as, and what is 10/5 the same as? Write their whole number equivalents above the number here and here. Okay, 5/5 is the same as 1, 10/5 is the same as 2. Okay, I want you to show me where 8/5 is. Okay, and I want you to think about this addition problem that we're going to do next as we went from 0/5 to 5/5, and then I went from 5/5 to 8/5. So that's what I ended up on. Write the addition sentence and to get me to my answer of 8/5. Okay, so I started with 5/5. Then how many more did I add to get to 8/5? I added 3 more, and that altogether equals 8/5. Okay, the thing about 8/5 is, again, it's an improper fraction. This numerator is way bigger than the denominator. So what I can do is I can change that number. I already know 5/5 is the same as 1 whole. That's what we said earlier. So 1 whole plus 1, 2, 3/5. So 8/5 is the same as 1 whole and 3/5. This is called a mixed number because it's a mix of whole numbers and fractions. And this is the proper way to write. This is the improper way to write these fractions. Okay, I think this is the last one. Draw one more number line and have your endpoints be 0/3 and 9/3. Pause the video while you do that. Okay, now what I want you to do is split this into chunks, 3 chunks. 1, 2, 3 chunks, and then label them with these numbers I've already given you. I got these because if I have 0 and I'm going to 9 and I'm skipping, I know this is going to be 3 chunks. I'm counting by basically thirds to get to 9. So 3, 6, 9 is how I got that. And notice my denominator stays the same the whole time. Okay, I want you to write the whole number equivalents. So what is 3/3 the same as, what is 6/3 the same as, and what is 9/3 the same as, and write it in the space above. Okay, 3/3 is the same as 1 whole, 6/3 is the same as 2 wholes, and 9/3 is the same as 3 wholes. And again, you can get that because fractions are just division problems. 3 divided by 3 is 1, 6 divided by 3 is 2, 9 divided by 3 is 3. Okay, with each of these chunks, I want you to split it into 3 more chunks. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9 chunks. Go ahead and mark those lines now. So you would end up with something that looks like this. Now the next thing I want you to do is mark the point 7/3. So just put a dot there, label it 7/3. And that is where 7/3 is, right after 6/3. Okay, I want you to come up with your own addition problem using these parameters. I want you to show it as 2 equal units. So how can I get to 7/3 adding 2 equal units and then 1 smaller unit? It's kind of like a puzzle. Equal means the same. So if you're ready for the solution, equal units, I know that this chunk and this chunk are worth the same amount. So there's 1 unit, there's 2 units, and then my third is a little bit smaller, just that one little gap. So you write the addition sentence, and there's also a multiplication sentence that could go along with this. So start with the addition sentence. What plus what plus what equals where I ended up. 3/3, that was my first chunk, plus 3/3 again, plus 1/3 equals 7/3. And I could represent this also as 2 copies of 3/3, because I had that 2 copies, plus, I'm going to add some parentheses in here since those go together, plus 1/3, I didn't mean to cover over that, equals 7/3. And what do we know about 7/3? It's an improper fraction. So what we can do to that is figure out, well, I know this is 1, this is 2, so there's 2 wholes right there. Then what's left over? 1/3. Okay, so figure out how many whole times 3 can go into 7. It can go in 2 times, and that makes 6 with 1 left over. So go ahead and do your exit ticket, see how you do on that, and I do want you to use a number line to show that. Your problem set is all going to be about, and homework is going to be about using number lines to show addition problems, because that is the why of how it works, and you should be able to explain it.